Hi everybody, this is Jeff Mankowski and welcome back to the Maverick Statistics channel. In this video, we're going to learn how we can use standardization to help us in situations where we have to compare observations from data sets that have absolutely nothing whatsoever to do with each other. For example, if we have a student that takes a history exam at a university and they're scoring 100 on it, and another student takes a history exam at a university and they're scoring 50, which student did better? Now, we probably want to use our intuition and say the person that did 100 because they scored 50 points ahead of the other student. However, there's a lot of factors that can kind of interfere with the comparison that'll screw us up. For example, we don't really know how many points each test was out of. We don't know if maybe one exam was multiple choice with 4 questions, the other exam was 20 pages long with essays. Maybe one professor was a lot harder than the other. One exam might have been graduate, the other exam was undergraduate. So there's all these different things that have a tendency to interfere with us. It's as if we're trying to do an apples to oranges comparison. Now, standardization is what will help us get everything on the same sliding scale for comparison. And the good news is to use standardization, we only need to know 2 things: the average and the standard deviation of a data set. Once those 2 are known for each data set, we can roll out standardization. So let's go ahead, bring an example up here on the screen, and let's see what's happening. This says, as part of an interview with a law firm, a candidate takes a typing test and scores a 100 words per minute on the test. It is known that the average score on this test is a 90 with a standard deviation of 20. Another person fishing for striped bass lands one weighing in at 85 pounds. Assume the average striped bass weighs 70 pounds with a standard deviation of 5 pounds. Use standardization to evaluate which person performed better, and you can assume all data is from a population. So 2 completely different things going on. On one hand, we've got somebody interviewing in a law firm, and that law firm, they probably have a lot of documents that need to be handled all day long, so they want somebody who's a very, very fast typist. On the other hand, we've got the person that's out there fishing, and when you're fishing, you want to catch a fish that weighs a lot, so the weight of the fish is really important. And our job is to figure out who did better, the person that caught the fish at 85 pounds or the person that got 100 on the typing test. So to start out, let's go ahead and let's just list what we know about each population on the side here. We're going to say typing, just like so, and then down here we'll put in fishing. And from the typing population, we know that the average is a 90, so we'll go in here, we're going to say average equals 90. Our standard deviation was given to us as a 20. And we know the person scored a 100, so we'll use X to stand for their score of 100. For the fishing case, the fishing population, average is equal to 70, while the standard deviation is a 5. And that person's fish weighed 85 pounds. So we're going to say X equals 85. And what we'll do to work our way through this is we're going to take the information that we have for both populations and get it on a number line so we can kind of draw a diagram. And then once we use the diagram to help us see what the solution is going to be, then we'll start to quantify it. So we can end up with a formula that'll work for any given standardization exercise. So we're going to start out by making a number line for each population here. Right in the dead center, we're going to list the average. Average typing score was a 90. The average fish weighs striped bass 70 pounds. And what we'll go ahead and do, in the case of the typing exam, let's mark the values that correspond to 1 standard deviation above and below the average. 1 standard deviation is a 20, so we're going to go ahead and write in 110 for the high side and 70 on the low side. Now, while we're here, we can also go ahead and pick a color. May as well indicate that that person scored a 100. So we're going to go ahead and write in there 100. We're going to make a little dot to indicate that. Now, let's do the same thing for the fishing case. We know that they scored 70. the standard deviation is 5. So let's go up about 1 standard deviation on each side. That means we're going to increase to a 75 here. And on the low side, we're going to drop down to a 65. Let's also go up another standard deviation. So we're going to go up to 80. We'll fall down to 60. And we may as well go ahead and do a third standard deviation so we catch the fish weight of 85 pounds. We'll put in here 85, and down here, of course, we're going to show 55 pounds. And let's go ahead and let's mark the fish they caught that weighed 85 pounds. Okay, so how do we solve the exercise from here? What we're going to be doing, let's go back to the typing scale, and we're going to take a look at the difference between the average and the score that that person got at 100. And we're going to ask ourselves, how many standard deviations are they away from the mean? The difference between 90 and 100 is going to be 10, and we know 1 standard deviation is equal to 20, so it must be true that we've traveled exactly half a standard deviation above the average. Let's go ahead and let's mark down on the side that we traveled half a standard deviation above the mean. In the case of the fishing population, let's do the same thing. Let's draw a line to show the difference between how much their catch weighed at 85 pounds and the average. We want to figure out how many standard deviations we've traveled here also. So let's draw a couple breaks in the line that will correspond to our sets of parentheses. From 70 to 75 is 1 standard deviation. So let's just say plus 1 sigma. 75 to 80 would be a difference of 5. So we're going to go ahead again and write in 1 standard deviation and over here as well. That means altogether, the person traveled 3 standard deviations. We're going to go ahead and just make this a little easier to read, 1 standard deviation. Now we're going to go ahead and we're going to write 3 standard deviations. What our job now is to do is say, okay, well, which person won, the 0.5 or the 3? And the answer is going to be the person who caught the fish weighing 85 pounds, simply because the 85 is more standard deviations above the mean than the typing score. That implies to us that the relative performance of the person who was fishing was much greater because their catch was 3 standard deviations above the average, whereas the person who took the typing test, they scored a score that was only half a standard deviation above the average. So not quite as far up there. Now, in case you're wondering, how do I quantify this? Because I don't want to have to draw a numerical scale on a number line each time I have a standardization exercise. How can I get a formula out of this? Let's go ahead and let's talk about formulas. We'll go back to the typing score of 0.5. And how do we actually get that number with a formula? Well, what we did remember was we were looking at the difference between 100 and 90 in terms of standard deviations. So what we can do is take 100, our score, subtract it from 90, and now we're going to take that difference and we need it in terms of standard deviations. And our standard deviation, of course, was equal to a 20 for that population. And 100 minus 20 is 10. 10 over 20 is 0.5. And of course, that corresponds with the number that we wrote down to begin with, right over here. In terms of symbols, what we just did was we took our x value, we subtracted it from the mu, and we divided it by the standard deviation of the population, which is our z-score straight back again. So we'll go ahead and we'll just attach a subscript to indicate that we standardized the score of 100. Now we're going to do the same exact thing for the fishing population. We're going to say we took the difference between the weight of 85 and 70, and we divided that by the standard deviation of the population, which of course gives us 3 again. And that let us go ahead and standardize the weight of 85 pounds. And now we know how to use standardization to evaluate an apples to oranges comparison. In the next video, what we'll do is we'll talk about what would happen if our z-scores come out negative instead. How would we react to that, and how we would be able to choose the best performance. I hope you enjoyed this video, and thank you for watching. This is Jeff Mankowski with Maverick Statistics.